Dear students, now we are going to discuss about work. Work you have already studied in your earlier classes. If we just define work, work can be simply written as transfer of energy. Whenever energy is transferred, indirectly we can call it work. But there are few conditions under which energy transfer can be considered as work. We can simply write one thing about work. Work is done when a force produces some displacement. Say, for example, a force is applied on a body, and if force is able to produce some displacement in the body, we say work is done, or we can say in that case energy is transferred. We just take up an example to understand it. Say on a ground we are having a block B, and say there is a boy A who is standing in front of the block. He exerts a pushing force F onto the block. As per Newton's third law, we can say that the block is also exerting the similar equal and opposite force F onto the boy. Now we can say, due to this force, if boy is able to displace the block in forward direction, say boy pushes and the block is displaced in this direction, then we say work is done on the block. And you can see this force which boy has applied on the block is displacing the body. Say the displacement is S. We also calculate the amount of work, that is the amount of energy which is transferred from boy to block. That can be written as work is equals to, it is magnitude of force multiplied by displacement of point of application of force in the direction of force. This is very important to understand that work is calculated by the product of magnitude of force and displacement of point of application of force in the direction of force. So this is the point where this force is applied. So we say this point, if it is displaced by a distance S, the work done can be written as F into S. This work is also measured in unit of joule, because work is the amount of energy which is transferred. So if boy who is applying a force F on the block displaces the block by a displacement S, then we say that the boy has given an amount of Fs energy, Fs joule of energy to this block, or we say boy has done Fs joule of work on this block. There are many cases in which force and displacement are not in same direction, like say if a block is placed on ground and a force is applied onto it at an angle theta from the horizontal. Now in this situation the block will experience horizontal and vertical component of the force, that is F cos theta and F sin theta. In this situation, if say this block is displaced in forward direction by displacement S, then we can simply state S is displaced by F cos theta in its direction, and in the direction of F sin theta there is no displacement of block. Here if we just calculate work done by force vector, this force vector, we can simply write this equals to F cos theta multiplied by the displacement. Or vectorially if we wish, we can write W is equals to F dot S, or it can be written as Fs cos theta, which can be rewritten as F dot S. So work can be written as dot product of force and displacement, because this dot product is also giving us that component of force which is acting along the direction of displacement, or vice versa, it also gives the component of displacement in the direction of force. Here if we talk about this W, this work which is being done in displacement of the block, this can be written as amount of energy transferred. This is the amount of energy which is transferred by the agent who is applying the force to this block. Now Work can also be considered in positive or negative signs. With positive or negative signs, if applied force is producing displacement in the direction of force, we can state work done is positive because F dot S becomes Fs or F cos theta into S. Say if some force is applied in opposite direction, say for example here friction is present. So friction will be opposing the motion. So whoever will oppose the motion, we can simply state work done by that force will be negative because force is opposite to displacement. So this dot product will result cos of 180 degree, that gives us negative work. Let us discuss once again about positive and negative work in detail. Always remember, work can be positive or negative. Let us consider the previous example once again, which we have taken at the time of understanding of work. Say we are having a block B. In front of this block, say there is a boy who exerts a force F onto the block. Block will exert the same force F in opposite direction according to Newton's third law on the boy A. Now say if block is displaced to the right, we can say in this situation if displacement is us, in this situation the work done by the boy is F into S. This work can be written as F into S because the applied force and displacement, they are in same direction. But if we talk about work done by block, block has exerted a force at the same point of application in this direction and the displacement is opposite to the force. If we calculate work done by block, this work can be simply given as F into S into cos of angle between them. So work done by boy can be written as Fs cos 0, so it will be Fs. In this situation, work done by block, if we calculate, this is the force which is applied by block. So it is F into S into cos of 180 degree, that will be minus Fs. Here this work is positive and this work is negative. Here you can see one thing, whenever work is done, always there is a pair of force which is acting at the point of application. Now out of the two forces, one force will be producing the displacement and other force will be opposing the displacement. Now the force which is producing the displacement is applied by the boy on block and the force which is opposing the displacement will be applied by block on the boy. As these forces are acting on different bodies, these can never be considered to balance each other. So in this situation, whenever work is done, two objects are involved or two bodies are involved, one will be doing positive work and other one who is applying the force opposite to displacement will be doing negative work. In this situation, always remember, when we talk about positive work, this implies supply of energy. As in this situation, boy is doing positive work, boy is producing displacement in block, boy is supplying energy to the block. Similarly, whenever we talk about negative work, which will always occur whenever positive work is done, it is gain of energy. Here, the block is applying a force opposite to the displacement. We can simply state block is doing negative work, or we say work is done on the block. As boy is opposing, it will gain energy. That's why we say negative work is gain of energy, because whenever there is some supply, there must be some object or body involved who will be gaining the energy. So whenever work is done, there is one body which is doing positive work or supplying energy, and there is always other body that should also be present in the system which will be doing negative work, or the one on which work is done, it will gain or accept the energy which is supplied. So be careful about this situation. Whenever work is done, always positive and negative work are done simultaneously in the same situation.